Now the graphs of cosine and its inverse. We have seen the graphs of sine and its inverse. Then for this cosine and its inverse, say exactly similar. Exactly similar. So first we draw the graph of cosine. For this function cosine is defined from r into minus 1. Also we know this cos inverse is from minus 1 into various subintervals, as in the case of sine. In these subintervals we have this inverse. So cosine function from this into various subintervals, and also we can have all the graphs of the branch of cos inverse in the same graph, of course, as in the case of this side. Now we consider this cos. For this, the two axes, horizontal and vertical axis. Along the horizontal axis, various points of this are 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, etc. Here is left minus pi by 2, minus pi, then minus 3 pi by 2, minus 2 pi, minus 5 pi by 2, minus 3 pi, etc. Towards the left. And along this y-axis, 2 points only marked, minus 1 and plus 1. Then floating points, various points. When x equal to 0, this pi equal to cos 0 v is 1. So mark the point here. 0, 1. X equal to pi by 2, cos pi by 2, which is 0. So mark the point 0. Then when x equal to this pi, x equal to pi, cos pi, which is minus 1. So mark the point here. 3 pi by 2, 0, mark it here. 2 pi, 1, mark it here. All these points, you know, so we do not go to the details. Then 5 pi by 2, here, 3 pi, minus 1, here. And again, cos minus pi by 2, 0. So, minus pi, is minus 1, here. Minus 3 pi by 2, 0, here. And minus 2 pi, 1, here. Minus 5 pi by 2, 0, here. Minus 3 pi by 2, minus 1, here. Marked points. Similarly, we can note all the points. Drawing these points by smooth curve. So we get so this is the curve for y equal to cos x. So for y equal to cos inverse, the graph of its inverse, y equal to cos inverse. So draw these. Along the horizontal axis, mark the points minus 1 and 1, minus 1 and 1. Then various subintervals. So all subintervals written. So we can have the components or graphs of this component, graphs of this branch in the same graph. So mark the points, various points. And we know this. For this inverse, in this component, in this subinterval, we see that this cos and its inverse are 1, 1 out. So we can have the corresponding points. Cos 0 is equal to this 1, therefore cos inverse 1 equal to 0. Similarly, cos inverse 1 equal to 0. Then cos pi by 2 is equal to 0. So cos inverse 0 is equal to pi by 2. So in that fashion we can mark the points. So cos 0 is equal to this 1, and this cos inverse 1 is equal to 0. So mark the point here, 1. In the case of pi by 2, point to this. In the case of pi, here, this cos pi is equal to minus 1. So cos inverse minus 1 is equal to pi. Then cos 3 pi by 2, 0. So cos inverse 0 is equal to again 3 pi by 2. So 2 pi. So the cases. Similarly here. Then cos minus 1. So here we see that this cos phi is equal to minus 1. So cos minus 1 is equal to phi. Here, this cos pi minus pi is equal to this minus 1. So it's inverse similarly. So we see that we can have these points, marking these points in that way. So this is the point here. Cos inverse, this one is equal to minus pi by 2 again. So minus pi, here the point, minus 2 pi here the point, and this is the point here, and again this result. So drawing the graph by smooth graph, smooth curve. So this is the graph of this y equal to cos inverse x. So thus we have the two graphs, the graph of cos and the graph of cos inverse. Cos inverse in various subintervals or graphs of these various branches of this cos inverse together. So this is the graph. Okay.